Do you think Summer, Gao, and Khalifa will watch this video later?
Maybe Carl.
Maybe. We'll say hello to Gao. Hello, Gao. Please like this video. Okay. Come on. Open up. Come on. Open. Oh, come on, open. Goodness sake.
Only one class.
Just one class, yeah. Okay, there you go, Ben. Wave motion. It's also called the wave equation. That one, yeah. That's right, yeah. Okay. So there's two types of waves. We have progressive transverse, also called S waves, and progressive longitudinal, also called P waves. So what exactly is each one? So progressive transverse wave is a wave that is made up of oscillations happening perpendicular to the direction of energy transfer. So, what is that? That is this wave. I'll show you with my hand. Oh, here we go. That's an S wave. So what happens is the wave goes this way and the oscillations, they are, you can see, perpendicular. Yeah, that's called progressive transverse, a transverse wave. Okay, and then the other type is called longitudinal, and you can write in a minute. Progressive longitudinal wave, the particles do not move with the wave. The particle movement is parallel to the direction of propagation. Now just some vocabulary. This direction here, you see this verb, propagate. Yeah, propagation, propagate. That's the direction the wave moves. Okay, and this part here, that's called the oscillations. O-S-C-I-L-L-A-T-I-O-N-S. So for this wave, it's moving like this. So the oscillations are in the same direction as the propagation. So it's kind of like it's vibrating out like this, you know. Okay, so now I'll give you a minute to write these definitions down. I'm sorry, lots of English for you. Lots of English. I think it's enough just to get that much. Is it? No, maybe you need the whole thing. Sorry. Yeah. The whole thing, Ben. Sorry.
Right, the whole thing.
The whole thing. You need the whole thing. Yeah. Yeah, got that? Good, okay. Wow, why are you so late? Huh? Yeah, so why are you so late? Okay. Okay, Ben, if you can draw these two waves. That's right. This is how you can make the S wave if you go like this. And this is how you can make the P wave if you push it in like this. Do you know what I mean? I think it'd be good if you can draw this picture. Oh, that's so beautiful. Okay. Okay, Ben. Right, now, some vocabulary. So, when we have a wave, we call the lowest point the trough. We call the highest point the crest. We call the distance from the middle to the crest the amplitude. And the distance from crest to crest is called the wavelength. Or trough to trough is also the wavelength. So I think it would be wonderful.
Opposite.
It would be wonderful if you could draw this. Parts of a wave.
It's S wave.
Yes. Although it's also true for a P wave. You are an artist, Ben. Artist. Got that? That's great, Ben. And also, I need this word here. So this is the displacement, and this one is the distance. So the wave travels a distance, and the particles are displaced along the way. Okay? Yeah? Yeah? Do you know this word, crest? It means the top, the peak. And trough means the bottom. Yeah, okay. So the letters we use, displacement is x. That's how far the particle is displaced by the wave. Amplitude is a. That's the maximum displacement. Wavelength is lambda. That's the length of one wave, from crest to crest or trough to trough. Period, T. What do you think that is? Time for what? One wave, yeah, one wavelength. Phase difference is the time difference between the crest of two different waves moving together. So I'll just explain that one. Say we have one wave moving like this, and we have another wave moving like this, you notice that the crests are a little bit separate. So here and here, there's a small difference between them. Okay, that's called the phase. The phase difference. Frequency. What's that? Well, that's how many waves you get in 1 second. How many cycles in 1 second. The speed, okay, the speed is how fast the wave is moving, propagating. You have this word still, Ben, propagating? Yeah, so that's, propagating means just the wave is moving, you know, we say it's propagating. It's like the wave is travelling. So, I think, now what you can do is you can write these letters down, and you only need to write the definitions down for the ones you didn't know. So for example, I think maybe you all knew F and you all knew T and you all knew V, but maybe you want to write this one down maybe, or maybe this one. It's up to you. Yeah.
What's the Greek letter called?
Oh yeah, want to guess?
What?
Want to guess? What do you think it's called? Have a guess. No idea? Ben, do you know its name? This Greek letter? No guess? Alpha maybe? Not alpha. Beta? Not beta. Keep going. Theta? No. Phi. Phi. Phi.
Phi.
Yeah.
What's that? Wavelength. Wavelength.
Oh, this one? Yeah, what's this one? Do you know? This one's phi, and this one? Lambda.
Lambda.
Lambda. Do you want me to write them down for you? Phi. Lambda. Oops. Yeah?
Okay.
Bum, bum, bum. What you listening to, girl?
Hmm?
What you listening to?
Someone asked me about else.
Ah.
You wanna go France?
France? You need IELTS for France?
I don't know. He said,
Cigarettes and pain medicine. You're not feeling well?
no.
Yeah.
But that's work for me.
It does work?
Yeah.
That's good.
So,
Panadol are good. Yeah. You have that, Ben? Yeah. Okay. So, remember that in mechanics we learned F equals 1 over T. That's still true. But we also have this new equation for today. This is our new equation. V equals F lambda. So, if you want to know how fast this is moving, the V will equal F lambda. The lambda, remember, is the distance from here to here, or from here to here, and the F is the frequency, the number of cycles. This is called the wave equation. Very simple, the wave equation. It's our only formula for today. Have you seen this before? It's new?
we have similar things in chemistry. Like we just half class, I think. Small class.
Your physics grades, I was going to tell you.
See? That's what I guess.
Yeah, well, I can't remember. I think, Ben, you just about got a B, I think. Like 60, 61 maybe. I think. And Gao, I think you just about missed a B. You got a C. I think you got 59.
Oh.
Yeah. So the two of you are very, very similar. Very similar.
Maybe opposite.
Or it could be opposite, yeah, maybe you got 61, you got 59. It doesn't really matter because, you know, the exam is worth 10%. So, you know, 5.9 or 6.1, both become 6 in the end. So it doesn't really...
So there won't be like B or C, just a percentage for the end of exam.
Yeah, you know, your grade is 10, 10, 10, 70.
What's the last 10? One is essay, one is this time. What's the last?
This is exam 1.
Yeah.
This is essay, coursework 1. This is the lab report,
Oh, yeah, yeah.
coursework 2, and then this is exam 2.
What was lock?
You know, you do the experiment, the lab report. You're doing it. You're doing it with Lorraine. I saw you had the notes with Lorraine.
No, we don't have.
I saw it in Ben's notebook where she was talking about this.
Yeah, but just in the classroom.
Yeah, but she's talking about this for your lab report. She's preparing you for the lab report.
Oh, today?
Oh, you weren't in today.
No.
You got this today.
I don't know
I saw. Take your chemistry out. I saw it in your chemistry.
what is this.
That's the. Oh, this one? Is that Oren gave us? No, I think that's from Ole.
It's too
Yeah.
Ole.
Lab results and calculations.
Yeah, 'cause that's she usually give us like this kind of paper, but we always practice like write down introduction or something, but we didn't start like essay.
Ah, okay. Okay, fine. Well, we do that in physics too. Yeah. Okay, continue. You have this? Right. Now, in the exam, they sometimes ask you for examples of different waves. So transverse waves go, we were saying, transverse waves move like this. Up, down, like this. Okay. So here's some examples. Light. Light is a transverse wave. Okay. Do you know any more waves? Can you think of any? Come on, think of a wave that goes like this.
C.
Yeah, correct. Ocean wave. Ocean wave. Good, good. Anything else? No? Waves in a guitar string. You know, if you have a string and you pluck it, it vibrates. Yeah. Now, what about longitudinal waves? So the first one is sound. So the sound moves out in a longitudinal wave like this. It vibrates out like this. It doesn't move like this. It moves like this. Yeah? Another example is underwater waves. Like, you know, if you have an earthquake underwater.
Earthquake.
Underwater. You know? So like you have your ocean and then you have the bed, the seabed, and it cracks and it starts to vibrate. It makes longitudinal waves. And the last one is in a spring. So if you had a spring and it was moving back and forth like this. Okay. Now in the exam they sometimes ask you for 3 examples. So there you go. There's 3 examples of each.
So
Longitudinal.
Longitudinal is like this. It's not this.
Yeah, no, it's vibrating like this. It's one second, Ben. I'll just show you the picture. You know that picture at the start there. S waves go up and down, whereas longitudinal go back and forth.
Okay.
Yeah. You'll have to watch the video at the start. Maybe I left a message for you.
Cappuccino?
No, cappuccino. No. What are you saying?
Ask him, do we have grade on chemistry?
Not yet?
Which I just go to the chemistry essay class.
Today?
Oh, didn't attend chemistry class.
Yeah.
Oh.
2 hours essay. It's talk about something.
2 hours? No, so we don't have chemistry today.
Yeah.
You had it this morning?
Huh?
Oh, go!
I don't know, I saw.
It's 2 hour essay class.
Oh, it's 2 hours?
It's 9 a.m. to 10 to 11.
Oh, will be a 2 per class with Wooden. Okay. So I didn't miss the chemistry class.
You missed your essay.
No, 'cause we didn't start yet.
Okay.
I don't know what's this.
Oh, do you need me to go back? Go!
No, just 2 words.
Okay. let's have a look at a question. A boy is sitting in a boat which is tied to the dock. Let's ask Ben. Ben, what's a dock? Or Gow, what's a dock? You know? You should know, you live in Skerries.
I don't know.
You want to tell him in English, what a dock is?
It's like small bay and there's lots of boats up in here.
Do you know what a bay is? No, try again.
There's like beside here is sea, but more close to you there have some place and just not too deep sea and you can stop boats or ship in here.
Okay.
You think you know?
Yeah, yeah.
Are you sure?
Yeah.
Here's my dock, and here's my sea, and here's my boat.
Mm.
There you go. A boy is sitting in a boat which is tied to the dock. The boat bobs up and down at a rate of once per 2 seconds. So the boat is going up and down as the wave comes in. Okay, and it's doing it once per 2 seconds. So that means the time is 2 seconds. Okay? The boy judges the distance between the peaks of the ocean waves to be 4 meters. So he thinks the distance between here and here is 4 meters. How fast are the waves moving? So that is, what's the speed of these waves? Alright, well that's easy. V equals?
F
Two.
lambda.
Lambda, good. What's F?
Half.
0.
Yeah,
1.
0.5.
0.5.
And lambda?
4.
And the answer?
2.
2. Easy peasy. Too easy. Yeah? Oh, good. Good. Look, today's lesson is easy lesson. So if you look here, how many questions I give you?
4.
Only 4. Yeah.
Yeah.
Yeah. Oh, I forgot to say, actually, that last one is interesting. So, your hearing, you can see in this last picture, you can only hear sound that's between 20 hertz and 20,000 hertz.
Yeah, we can't hear it.
You can't hear past that or below that. Yeah. Now, when you get older, this number, this 20,000, gets smaller. So, for example, maybe I can hear between sound between 20 hertz and maybe like 18,000 hertz because I'm older.
I've seen
Maybe you're the same. In the September students, I could find only one student who could hear 20,000.
How?
What I did, I played a
video.
video, yeah, and she's the only one that could hear the 20,000. Nobody else could hear the 20,000. So as you get older,
So she's really young.
yeah. She's like 18. Yeah. So maybe Ben could hear 20,000. You're the youngest, aren't you?
19.
Yeah, so maybe you could hear this. How old are you, girl?
I will be 20 next month.
Okay, so maybe you could hear it as well. Yeah. So I'd say, I don't know, maybe it's like every 10 or 5 years it goes down by 1,000.
My ear is really bad. I even can't hear someone called me.
Okay, maybe you're 17,000 then. Yeah. Okay, so I think that's interesting. And you know this animal, don't you?
Bat.
The bat, yeah, it can hear the highest. And this animal, the elephant, can hear the lowest frequency. Because I think they can hear it in the ground. You know, they can feel it in the ground. Yeah. Okay, I'll let you try these questions now for a few minutes. Here we go, I'll close this. Yeah, there's 10 minutes left. You should be able to do these in 10 minutes, I hope.